Okay, welcome back. Last time we discussed how to simplify radicals with negatives under the square root, and now we are actually going to use that idea to solve equations that have complex numbers in them. So let's take a look at how that works. So we are going to solve equations with complex numbers using square roots. And just like we did before, we are going to isolate the squared term. So we're going to get that part of it that's squared all by itself by adding or subtracting or dividing or anything like that that we need to. And if there's a negative under the square root, we pull out the I and simplify as we learned earlier in the chapter. So let's take a look here. Okay, so as we start solving with square roots, couple of things to remember. We're going to have some complex numbers that are our answers for some of these, and we need to remember that anytime we can pull out a negative 1 as a square root, the square root of negative 1 is I. So as we look, we have x squared plus 4 equals 0. Well, the first thing we want to do, like I said on the previous slide, is we want to get the squared term by itself. Well, x is being squared, so I'm going to go ahead and get anything that's with it away from it. So I'm going to subtract 4 from both sides. And I get that x squared equals negative 4. And then to undo the square, I would take the square root. In the last section, we would have just said that this is no real solutions. Well, now we know that if we have a negative under the square root, I can pull out that negative 1 and the square root of 4. Okay, so that's just a factor pair of negative 4 is negative 1 times 4. And the square root of negative 1 we said was I, and the square root of 4 is 2. So we'd have 2I. And of course that means there's two solutions also, so we always put our plus or minus out in front. Okay, just getting a little bit more difficult here, just adding some steps into our solving. So I have 2x squared minus 11 equals negative 47. If I get that x squared all by, or the squared term all by itself again, I want to get x squared alone. So I'm going to add 11 to both sides. And I get 2x squared equals negative 36. If I divide both sides by 2, I get that x squared equals negative 18. And then I'm just going to take the square root. And thinking about how I'm going to simplify that square root of negative 18, I'm going to take out the negative 1, the square root of negative 1, and I'm going to think of factor pairs of 18 that have a perfect square. 9 times 2, 9 is a perfect square, so I'm going to use the square root of 9 times the square root of 2. And I get the square root of 1 is I, the square root of 9 is 3, times the square root of 2. So I'm going to have 3I times the square root of 2, and of course I always need to have the plus or minus out in front. Okay, moving on to some more examples. Again, they just keep getting few more steps in here. Again, I need to get my squared term alone. So I have x plus 2 is being squared, so I need to add 9 to both sides. And I have x plus 2 squared equals negative 6. I'm going to go ahead and take the square root of both sides. And I have x plus 2 on the left. And I have the square root of negative 6 on the right. And again, if I'm thinking about how I can simplify that, I'm going to take out the square root of negative 1. And I'm left with the square root of 6. So I have I times the square root of 6 on this side. I need to get x all by itself. So I'm going to subtract 2 from both sides. And I have x all by itself over here. These terms are not like terms. And don't forget we have to have a plus or minus there. So I'm going to have negative 2 plus or minus I times the square root of 6. These parts do not go together. You can't put negative 2 and I together or anything like that. It just stays as an answer. Negative 2 plus or minus I times the square root of 6. So let's look at how another one might look. X minus 7 squared plus 12 equals 4. Again, I need to get my squared term all by itself first. So I'm going to subtract 12 from both sides. and I get x minus 7 squared equals negative 8. I need to take the square root of both sides, and I have x minus 7 over here. And if I'm thinking about how to simplify the square root of negative 8, I'm going to take out that negative 1. And I'm thinking of a factor pair of 8 that has a perfect square, 4 times 2. So that would be the square root of 4 times the square root of 2. I know that the square root of negative 1 is I, the square root of 4 is 2, and then the square root of 2 is just the square root of 2. So I'm going to have plus or minus 2i, that's going to be these two simplified, 2i, times the square root of 2. I'm not done yet because I still need to get that x all by itself, so I'm going to add 7 to both sides. Again, those terms are not like terms, so that 7 stays by itself, plus or minus 2i times the square root of 2. Okay, that doesn't become 9i, it doesn't become 5i. The 7 and the radical are not like terms, so you do not put them together. Okay, so you go ahead and try a couple of them. So pause the video right now, please, and give yourself a minute and see what you come up with, and then check the answers with what I put on here. And if they're correct, great. If they are incorrect with what you have, please check with the teacher, and we can help to see if we can find where you helped, or help to find where you made a mistake. Okay, so check what you have with what I have. And again, if everything is correct, you can move on. If it is incorrect, please raise your hand and get some help. Okay, so the other way we are going to solve quadratics with complex numbers is by completing the square. And we did that a little while ago, so I figured I would go back and just review the steps on how to complete the square, and then we'll actually get into some answers that have complex solutions. So let's just remember how we do that. Before we start, you always want to make sure your equation is set equal to 0. So if there's a y in your equation, you make y 0. If there's a number on one side of the equation, you move it to the other side so that all the terms are on one side and it is set equal to 0. So in this case, the first thing we're going to do is I'm going to get it set equal to 0. So I'm going to say, and I'm going to put the 0 on the right side because I prefer to have the 0 on the right side. So I'm going to say that x squared minus 12x plus 25 equals 0. Okay, so then we are just going to go through our steps on how to complete the square. And there's some of you, I think, that are still struggling with this a little bit. So let's make sure that we know how to do that because we're going to need that for this section. So the first thing, you group the terms with the x's. So I'm going to group my x terms. I'm going to say x squared minus 12x. And then inside of my parentheses, I'm going to add something. So I still have that plus 25. And on the outside of my parentheses, I'm going to subtract that same something. Whatever I added on the inside, I'm going to subtract it back out. When you do that, it basically, it's just like adding 0 because you're adding and subtracting the same thing. So again, how do we figure out what we're going to add and going to subtract? We have our set of parentheses down here. So it says create a perfect square beneath the parentheses. So right underneath of our parentheses, we're going to take and say x. Okay, what goes in here is going to be half of b. Okay, so b equals negative 12. Negative 12 divided by 2 is negative 6. So we're going to go minus 6 in here. And then you square it up, meaning you are going to take your negative 6, you're going to square it, and that's what goes in your boxes. So you're going to have plus 36 and minus 36. And I forgot to put my little square there. So I have x minus 6 squared, and then if I have plus 25 minus 36, 25 minus 36 is negative 11 equals 0. And now we're pretty much right where we were on the last slide where we have this equation. that's being squared, so we can solve that. So let's go ahead and do that. So we are going to get those squared terms by themselves. So we want that by itself. So I'm going to add 11 to both sides. So I have x minus 6 squared equals 11. I need to take the square root of both sides, and I have x minus 6 equals the square root, plus or minus, excuse me, the square root of 11. And right now there's no negative square root underneath of the radical, so we're fine to just add 6 to both sides. We can't simplify the radical either, so we're going to have x equals 6 plus or minus the square root of 11. So that was one of the examples that we did with completing the square a couple weeks ago. This is how you actually go through and solve it, by completing the square. Okay, so let's do a couple of them together, and then I'm going to have you try a couple of them on your own. Okay, so the first thing, we want to make sure it's set equal to 0. We already have it set equal to 0, so that's good. So the next thing after that is we are going to group our parentheses here. So I'm going to group my x terms. So I'm going to have x squared minus 10x. Inside of my parentheses is some plus something. The minus 14 stays there, and then I'm going to subtract that same something. Okay, I'm going to make my perfect square down below. Remember, inside of that parentheses is going to be half of b. So we're going to have half of negative 10, which is negative 5. And then we squared up. Negative 5 squared is 25. So we're going to add 25, and we are also going to subtract 25. And negative 14 minus 25 is negative 39. And again, we want to get our squared term all by itself. So I'm going to add 39 to both sides. And I have x minus 5 squared equals 39. Next thing I need to do is take that square root of both sides, and I'm left with x minus 5 equals plus or minus the square root of 39. If I have to think in my head really quick, are there any perfect squares that go evenly into 39? Well, 4 does not, 9 does not, 16 does not, 25 does not. So there's nothing we can simplify. It's not negative underneath of the square root, so we're just going to leave it as it is, and I'm just going to add 5 to both sides. And I say that x equals 5 plus or minus the square root of 39. Okay, so let's go ahead and look at one that actually has a complex solution. So if we look at number 2 over here, okay, remember our first step that we did was we wanted to make sure we got it set equal to 0. Well, currently it says equals 4, so I want to subtract 4 from both sides. And I get x squared plus 6x plus 29 equals 0. Now we can go through the process of completing our square. I'm going to group our x's. So I have x squared plus 6x. Inside of my parentheses, I'm going to add something, plus 29, and I'm going to subtract that same something, equals 0. And make my perfect square here. Remember, what goes in the parentheses is half of b. 6 divided by 2 is 3. And then I square 3 and I get 9, so I'm going to add 9, and I am also going to subtract 9. So 20, oops, sorry, I meant to highlight that, not, let me fix that really quick. That's plus 29 minus 9 in the box. Oops. So what I was trying to do is highlight that says 29 minus 9 is 20. So that's where we're going to get plus 20 right here equals 0. Now we need to, remember, get our squared term by itself. So I need to get x plus 3 squared. So I'm going to go ahead and subtract 20 from both sides. And I get x plus 3 squared equals negative 20. I need to take the square root of both sides. And I get that x plus 3 equals plus or minus the square root of negative 20. So I need to think, okay, I have a square under here. I have a negative, so I know I need to pull out the I. So I need to pull out the -1. And what factor pair of 20 has a perfect square? So we'd have the square root of 4 times the square root of 5. So I'm going to rewrite this here, x plus 3. I'm going to leave that there for a second, equals plus or minus. When I simplify the square root of -20, the square root of 4 is 2, the square root of -1 is I, and the square root of 5 is just 5. So I would have 2I times the square root of 5. And then in my final step, I just need to get that x all by itself. So I'm going to subtract 3 from both sides. And I get x equals -3 plus or minus 2I times the square root of 5. Okay, so now I want you to try these two where you make sure you get it set equal to 0, complete the square, and solve it. There's a lot of steps that go here, so I want you to finish them, pause the video. I'm just going to put the solutions up, and again, just like last time, if you get it correct, that's great. If you get it incorrect, please raise your hand, and the teacher will come and kind of look through your work, so make sure you have your work shown on how you got your answer so we can see how you got it, and maybe find an easy way to find a mistake that you might have made. But if you get them right, great job. Okay, so go ahead and check what you got with what I got. And again, ask questions as needed. And good luck on your homework. So your homework in Schoology, there's a worksheet that's called Solving Quadratics with Complex Numbers. And you need to complete that homework and resubmit it back into Schoology, please. Have a good day.